All right, welcome to linear inequalities. This is an introduction to linear inequalities, basically where we're going to talk about what actually is an inequality and some words associated to it, graphing it on a number line. Okay, that's kind of, and then just translating it from words to inequalities. So basically, an inequality is a mathematical statement that contains the symbols that are pretty much less than, greater than, less than or equal to, or greater than and equal to. Now, I do have an example of equations versus inequalities. So equations is when you have a variable equaling one specific number. An inequality is where a variable could equal like an infinite number of just an infinite number of numbers, and but it does have a restriction. So in this particular case, x has to be greater than 3. So it could be 4, it could be 5, it could be 10, it could be 19.7, it could be anything except it cannot be less than or equal, like it cannot be 3 or less than 3. Okay, now graphing solutions to linear inequalities in one variable. So we're going to use a number line, and now this depends on your professor and what they prefer, but you're going to use brackets at endpoints of intervals if you want to include the number. So anything that has the equal, so that little bar underneath means and equal to. So anything that has and equal to, you're going to use parentheses. You could also use what we call a closed circle. Okay. Now you're going to use parentheses for anything that does not have the and equal to sign. You could also use an open circle. Okay. So this next set of examples shows you what you would do. So for example, below is a graph of x is less than or equal to 7. And I'm just going to write that in words, where x is less than or not of, or equal to. Okay, so that's how you would read that. Notice because the or equal to or and equal to, we are going to use a bracket. You could also use a closed circle. Okay, so that's how you would do it with a closed circle. And then you're going to shade all the numbers that are less than 7. So you would actually shade to the left of 7. So you could do kind of a different color like that. That's what I'm going to do. I'm going to just shade, and then you do kind of like a big arrow. Okay. Now for the next one, we have the graph of x is greater than -4. So because it's greater than, okay, then we're going to use parentheses. You could also use, here's -4, you could use an open circle. And then again, you are going to shade in the direction. So because x has to be bigger than -4, you're going to shade everything that's bigger than -4. Okay, and I just grabbed a highlighter and kind of made an arrow a little bit bigger. Now, I do have this chart. I would highlight this chart, take a picture of this chart, write it down on a piece of paper, but this chart is actually incredibly helpful because it tells you all the words that could potentially go with the symbols. Okay, I'm not going to bore you by reading it. You can read it yourselves, but I'd take a moment right now and screenshot this, take a picture of it, do whatever it is you need to do, put it on a different piece of paper. Okay, and let's do a couple of examples. So inequalities. X is less than 3. Okay, so if we graph it, we're taking a look at 3. I'm going to use circles. Okay, because it's not an equal to, I'm going to have an open circle, and then I have to decide which direction am I going to shade in. Okay, so 3 is the biggest number, which means to say x has to be less than my biggest number. So I'm shading in this direction. Now, interval notation. When we're talking about interval notation is we are doing parentheses. Now, I always like to include negative infinity all the way to the left, positive infinity all the way to the right. So basically what we're saying is we want to include all the numbers, the entire interval that's shaded. And where does that interval start being shaded? And keep in mind, you're always reading the number line from left to right, just like you're reading a book. So it starts at negative infinity, okay? And we are including all the numbers up to 3. Now, for interval notation, we have to use parentheses, brackets, or you could use a combination of parentheses or brackets. Because I have an open circle, it's the same thing as if I were to put a parentheses there, okay? The other thing I want to note that you always do parentheses with infinity. So interval notation would be negative infinity to the number, which is 3. And then we have to decide, are we using parentheses or brackets? Because it's not an equal to, then we're going to use parentheses. Just like here we used an open circle, it's the same thing as if we used a parentheses. So we would do a parentheses there as well. And we just did interval notation. Okay? Now, the next one, x is greater than or equal to negative 1. So here we would use either brackets, okay, or we would use a closed circle, just like here you use parentheses or an open circle. So I'm going to do on negative 1, that's what we have to find, closed circle, because it's and equal to, and now we need to make a choice. In which direction do we shade? Well, x is the bigger number. So that means to say I have to shade all the numbers bigger than negative 1. So I have to shade to the right. Now, just like I did before, I'm going to label negative infinity to positive infinity because that's what my numbers go. And the start of my interval is negative 1. We go from left to right, just like reading a book. So here's my start, and I'm going to use all the numbers up to positive infinity. So now my interval is going to go from negative 1 to positive infinity. Since I'm using infinity, that always has to have a parentheses. However, to start the interval, we need to decide, are we using parentheses or brackets? Well, I used a closed circle right here, which means to say I need to use brackets. Okay, so that's how that would look. All right, now let's talk about in words here, translating this into words. We're not going to actually solve, we're just going to translate. So the solution of the interval, okay, so 12, so we're not going to do this part, we're just going to translate. So 12 times C is no more than 96. So we have 12, and that's times C, and then it's no more than 96. So we need to kind of figure out what no more than is. So if we take a look, we have more than, okay, at most, is no more than. So this is the symbol that we are using, okay? So we need to kind of figure out what it is that we are looking for. And if you think about it, makes sense. 96 is the most it could be, all right? 12 times C has to be smaller than 96. And so that's how we would get, translate that. Whoops. Okay, so again, we're just going to translate. We're not going to solve or anything like that because we don't have all the tools yet in order for us to be able to do that. So we have 30 less than x. So less than x always tells us that that's minus. And keep in mind that we have to switch these two around. So x minus 30, because it is 30 less than x. So x is my bigger number and I'm subtracting 30 from it. Is at least 45. So I have to have 45 here. Is at least. So could it be more than 45? Yes, it could. But can it be less than 45? No, it cannot. Could it be equal to 45? It could. So I'm going to take a leap of faith and use that symbol. If we go back here, is at least is located right here, which means that is the symbol that we have to use for this, which is the correct symbol that I used. So keep in mind, it's not always like we can use our intuition here and kind of be thinking about it logically, but I wanted to kind of give you a little bit of a frame of reference that you could use if you're struggling with the wording. Okay. So I do have a few examples on here of different things that you could see. Next video is going to be on solving linear equations. Linear inequalities. So I'll see you in the next video.